Hello, in this video, we will be seeing the jump game problem with a variant that asks us to compute the minimum number of jumps to reach from the start of your input array to the end of your input array. Having said that, the input will be such that you will always be able to reach from the start to the end. And we will be building a solution in JavaScript and also compute the time complexity and space complexity of the solution that we will be building. Now we said that you go from the start to the end and you will have at each index the value representing the farthest jump you can make from that specific index. So you are at index of 0. From this you are having 2, so you can jump 2 indexes. So you go from here to here to here. So this is the maximum jump from this index that you can make. And because we said that we will always have this constraint wherein you will be able to reach from the start to the end, we can try to take a greedy approach because we want to find the minimum number of jumps which will be possible. So to try to find something minimum, we can try to be greedy and see that what is the maximum jump that you can make at a specific jump sequence. So if you are making 2 jumps, the first jump you will try to jump the farthest, and from the second jump also you will try to jump the farthest. This solution might not be the optimal approach, but the consideration is that at each local approach you will try to see the best possible scenario. That's the greedy aspect of it. We don't really focus on the final optimal solution, but we try to focus on the local optimal solution that we try to reach. And having said that, let's jump into the execution aspect of it. We will be using 3 pointers. 1 pointer to keep track of the farthest jump that you can make from a specific index. 1 pointer to keep track of the current jump that you have made, and another counter to keep track of the total jumps that will be required, which you want to make it minimal. We will start with our 2 pointers at the 0th index. What I mean by that is I will take the 2 pointers that I have, and with these 2 pointers I will place them at the 0th index in my input array that I have received. And having put them at the 0th position, I will try to go from the 0th index to the second last index, because I just need to make jumps to reach the second last position in my input, because then you reach the last position and from here you don't want to go anywhere. So you just want to make sure that you reach here. So we will try to see what is the number of jumps that will be required to reach this position. That will be the second last position in your input that you have received. Having said that, we will initialize our counters. So I will have total jump counter of 0. I will have my farthest jump counter also to 0 and my current jump also to 0. And then I will pick my farthest jump pointer and I will say pick the maximum from the current max jump that you have. So 1 is your current jump and 1 is your farthest jump possible. So this will be compared with the farthest jump that you have, and we will say the jump that can be made from this point is basically represented as I plus nums of I, with nums being a input array that we receive. We are at index of 0, so our pointer lies at 0th position. We will say 0 plus what is the index at 0 having value, which is 2. So we have value of 2 at index of 0. I will say 0 plus 2, which is going to give me 2. Now this pointer will be going to position of 2 because that's the farthest you can go from your 0th index. So I will then take my 0th index farthest jump pointer, and I will go ahead from there to 1 and then to 2. So I will reach at position 2. Then what I will do is I will say whatever my I is, at this point my I is 0. So I being 0, I will see after I make the farthest jump possible from my ith index, which is 0 currently, I will see what is the value of my current jump. My current jump value is 0. My I is also 0. If my I matches my current jump value, then what I will do is I will increment my jump count. So I will decide that I want to jump now, and I will also increment my current jump from this position to wherever I predicted that I could jump the farthest. So first I saw, hey, move your farthest jump pointer to as far as you can go. That is step 1. And step 2 is, once you have told your farthest pointer to reach the farthest possible point and your index is matching the current position that you are at, then you will say make the actual jump. So you will go from the 0th position to wherever your farthest jump pointer is, which is at this position. So you made your first jump, you incremented your jump counter, and you have also made sure that the farthest point will be updated now from 0 to 2, because that's where you are at, and your current jump is also at 2, which is at this specific index of 2. Now we will do the same thing again that we did in the first iteration, wherein now we first had the pointer at the 0th position for I. Now this pointer will move from the 0th position to the first position. So now I will be here. So now having I as 1, I will again see what is the farthest possible jump that can be computed with this I and its own value. So I being 1 and nums of I being 3, it gives me 4. So it says that the farthest possible jump that can now be made is with 4 indexes jump, and my current farthest jump value was 2. So now what I will do is I will shift my pointer from position of index 2 and I will say move it to 4, because that's the higher value in comparison to 2. So now from 2 it will go to 4, the 4th index that I have with me, and I will also update my farthest jump that can be possibly made to 4 now. Then I will compare my I, which is currently 1, with my current jump. This is not same, so I have not yet reached a point wherein I can just make the jump. I have to move my iteration to the current position I am at, because the reason being that I am trying to see what is the best possible jump I can make. So I will try to see the possibilities that I have, which will keep on iterating until I reach my current position from the previous jump that I made, and I will see what is the best possible farthest jump that I can make, and I will keep on updating it if the value I encounter is higher until I reach the current position I am standing at. So I am currently standing at this position after I made my first jump, which is indicated by this 1. Now I will try to see reach from the previous position to your next position. Keep on iterating your I and try to find the maximum farthest point that you can jump to. So now we updated this farthest point. I will keep iterating again now. I will say that now I is going to be 2. At I2, the index currently exists. So I am currently at I is equal to with my current jump pointer that I have, and from this point now I will have to make a jump. I will again compare whatever value I have here, which is basically index of 2 plus the value which is 1. So 2 plus 1 is going to give me 3. 4 and 3, if you compare, 4 is still higher. So this is not the farthest you can jump. You have already found the farthest you can jump now for the second jump from this value, and you have reached your current position as well. So when you are at your current position and you know what is the farthest you can jump, then what we will do is we will just make the jump. So you will go from the current position that you have to the farthest position that you have decided, and you reach this specific point, and that's pretty much it. The aim is to reach from the start to the end, and you have to find the minimum number of jumps. So first jump we made and we reach index of 2, and from index of 2 we made another jump which reached our index of 4. So I will just say increment my jump counter, and having reached the end of my input and also found the jump count, we have reached a solution. Now let us convert whatever we covered with this greedy approach into code, and it will look something like this. We will say keep a counter, so let total jumps that you are going to make be 0, and in the end we are just going to be returning whatever total jumps we can make, because this total jumps is the value of the minimum jumps that we want to make to reach from start to end. That we will go from the start till the end of the input that we have received, and once we have reached the end with the second last element, we will just stop. So what that will look like is something like this. I will just use a for loop. I will say I is equal to 0, I is less than nums dot length minus 1, and I will just say I plus plus, and I will be having this total jumps counter incremented whenever I can make the farthest possible jump, and that farthest possible jump will be decided by the 2 pointers that we keep. That is going to be the current jump pointer that you can have. So I will have a current jump pointer which is initially 0, and I will also have the farthest jump pointer which will also be 0, and with these 2 pointers I'm just going to move from the start towards the end of my input array that I have received. So I will say my farthest jump that can be made is going to be the max of my current farthest jump plus the iteration that we followed, where we said I plus nums of I. So I will say I plus nums of I, and whichever is higher, and this being the greedy aspect, when you want to find the farthest you can jump, we will just pick as a latest farthest jump value. And after we have picked this, we will see if the counter of my iterations have reached the position I am currently at. I go from the start towards the end, and once I make my jump, I will have a gap from the position I made the jump from to the current position, and I will try to see within this input what is the farthest jump I can make, and that will look something like this. If I have reached my jump position, which is going to be I being equal to my current jump that I have, then I can say that I am ready to make a jump. So I will increase my jumps counter, and I will jump to the farthest point that is possible. The farthest point that is possible is in my farthest jump. So I will just say current jump is equal to my farthest jump. So I make the jump here, and that's pretty much it in terms of implementation. And in terms of the time complexity that we will be having is going to be big O of n, because we go from the start until the second last element in my input array that we have, and that's going to be big O of n minus 1, and 1 being the constant, it's big of n. And in terms of the space complexity that's we're going to having, it's going to be big of 1, because we just use this 3 counters and no additional data structure or any other storage is being used, and we just keep on overriding the values that we have and incrementing the total jumps count. So this is going to be big of 1, big of 1, big of 1. It's adding up to big of 1 itself because it's constant. And that's pretty much it. Thank you for watching. Please like and subscribe.